the Göbekli Tepe vulture stone. The year is somewhere between 9,600 and 9,000 BCE. The confirmed construction window of one of the most extraordinary sites ever discovered. You are standing on a barren limestone hilltop in southeastern Turkey, surrounded by people who, according to every textbook ever written, should be primitive hunter-gatherers. No cities, no writing, no civilization. And yet they are dragging 20-ton pillars into precise circular arrangements and carving them with images so specific, so deliberate, that a team of engineers at the University of Edinburgh's School of Engineering spent years attempting to decode them, and concluded that one particular carving, on a pillar now called the vulture stone, records the exact night the sky fell. The carving shows a vulture holding a sphere above a headless human figure, though archaeologists note the same figure also bears a prominent phallus, suggesting a more complex narrative than simple death imagery, surrounded by animals arranged in a pattern. In 2017, Martin Sweatman and Dimitrios Tsikritsis published their analysis in Mediterranean Archaeology and Archaeometry. Yeah, the animals, they argued, mapped to specific constellations as they appeared on approximately 10,950 BCE, a date that overlaps with the onset of the Younger Dryas, a sudden catastrophic cooling that collapsed temperatures within decades. Some researchers have proposed, based on ice cores, platinum deposits, and sediment layers across multiple continents, that a fragmented comet triggered this event, though the Younger Dryas impact hypothesis remains actively debated and is not accepted as consensus by the broader scientific community. Radiocarbon dating places the site's construction between 9,600 and 8,200 BCE, making it at minimum 11,600 years old, 6,000 years older than Stonehenge. Mainstream archaeology describes the animal carvings as totemic symbols, not star maps. The comet interpretation remains contested, and notably, the actual archaeologists excavating Göbekli Tepe published a formal rebuttal in the same journal, arguing that the proposed date of 10,950 BCE for the carving is itself 700 to 1,000 years older than the earliest radiocarbon date confirmed for the enclosure containing the vulture stone. But the statistical probability that random carvings accidentally match the correct constellations for one specific catastrophic date is not a comfortable number. What if the vulture stone isn't mythology? What if it's a newspaper, pressed into stone so the next world would know what destroyed the last one? From a hilltop that encoded a cosmic catastrophe, we descend into water, and something pulled from the seafloor that should not have existed for another 15 centuries. The Antikythera mechanism. In 1900, sponge divers off a tiny Greek island discovered a Roman shipwreck sitting 45 meters below the Aegean. The following year, among the objects hauled to the surface was a corroded lump of bronze that nobody paid much attention to. It sat in the Athens Museum for decades, misidentified as debris. Then an X-ray machine looked inside and found gears. 30 gears survive in the fragments, with analysis suggesting the original device contained at least 37 meshing bronze gears. And the 2021 reconstruction by University College London proposed as many as 69 in the complete mechanism. The engineering is extraordinary. Gear teeth cut to approximately 1 millimeter, epicyclic systems of remarkable ingenuity, all packed into a device the size of a shoebox. Researchers working across international collaborations, culminating in the University College London Antikythera research team's landmark 2021 study, determined that this device computes solar and lunar eclipses using the 18-year Saros cycle, tracks all 5 planets known to antiquity, models the irregular elliptical motion of the moon using a pin-and-slot epicyclic gear, and displays the 19-year Metonic calendar cycle. the mathematical relationship between 235 lunar months and 19 solar years. Its eclipse predictions, when checked against modern retro-computed data, are accurate to within hours. Nothing of comparable mechanical complexity appears in the historical record for another 1,400 years until medieval European astronomical clocks of the 14th century. The mainstream view is that it represents an isolated peak of Greek engineering genius, possibly in the tradition of Archimedes, never replicated. But no surviving Greek text describes how to build it. If one genius made it, where are the workshop notes, the apprentices, the tradition? A 2016 study by Alexander Jones of New York University identified inscriptions on the device explicitly naming planetary cycles, confirming it was a predictive instrument. Someone understood the math deeply enough to cast it in bronze. Then that understanding vanished so completely that civilization spent the next millennium without gears. From the seafloor of the Aegean, we travel south to the ceiling of an Egyptian temple, and a star map that shows a sky no living human had ever seen, the Dendera Zodiac. Imagine being a French soldier in 1820 and watching your commanding officer order workers to saw a circular sandstone relief from the ceiling of an Egyptian temple at Dendera. The disc they removed, now in the Louvre in Paris, is a star map. Carved around 50 BCE during the Greco-Roman period of Egyptian history. But embedded within it are astronomical markers that only make sense if the original blueprint was drawn thousands of years earlier when the same stars occupied completely different positions in the sky. The precession of the equinoxes, the slow wobble of Earth's axis that takes 25,920 years to complete one full cycle, shifts which constellation rises at the spring equinox over millennia. The Dendera zodiac depicts the constellation Leo positioned directly above the figure of the Sphinx, a configuration that matches the sky at the spring equinox around 10,500 BCE. That is 7,000 years before mainstream Egyptology says Egyptian civilization began. Robert Bauval's 1994 Orion correlation theory proposed that the three pyramids of Giza mirror the belt of Orion as it appeared around the same era. A claim that, like the Dendera precession argument, is disputed by mainstream Egyptologists who question both the dating methodology and the precision of the correlation. Egyptologists largely interpret the Dendera zodiac as a ceremonial sky map of the Greco-Roman period, arguing the precession alignments are coincidental. But the disk is not imprecise, it is measurably, verifiably accurate. And the temple's own foundation texts state that its plans were handed down from the time of the followers of Horus, a mythological era the Egyptians themselves placed long before the first pharaoh. Supposedly coincidental. But who were the followers of Horus? And how did they know what the sky looked like 10,000 years before they were born? From a ceiling that remembered an ancient sky, we move north to a muddy German field and a bronze disk that should not exist. The Nebra sky disk. In 1999, a man with a metal detector struck something in a field near Mittelberg Hill in Saxony-Anhalt, Germany. He dug up a disc of bronze 44 centimeters across and sold it on the black market for 31,000 Deutsche Marks, with no idea he had just found the oldest known realistic depiction of the cosmos. German authorities recovered it in 2002. It was authenticated by archaeologist Harold Meller and inscribed on UNESCO's Memory of the World Register in 2013. The disc depicts a golden sun, a golden crescent moon, and a cluster of stars. Astronomer Wolfhard Schlosser of Ruhr University Bochum confirmed the star cluster matches the Pleiades as they appeared at the spring equinox around 1600 BCE. The gold arc along one edge spans exactly 82 degrees, the precise difference between the summer and winter solstice sunset points at the latitude of Nebra, Germany. Archaeoastronomer Emilia Pastor confirmed this is not approximation. It is exact. The disk was calibrated to a specific geographic location on Earth by Bronze Age people who, according to the mainstream timeline, possessed no known astronomical mathematics. The official interpretation, that the Unitis culture of Bronze Age Germany was more sophisticated than assumed, is accepted by scholars. But the Unitic left no written records of any kind, no texts, no astronomical tables, no equations. Isotope analysis traced the discus copper to the Austrian Alps and its gold to the Carpathian Mountains, meaning the materials were traded across hundreds of kilometers. Someone assembled this from a continent-spanning supply chain. 3 distinct phases of modification are visible on the disk. It was updated, corrected, refined over generations. Who was maintaining it? And based on what ongoing observations that nobody wrote down? From a muddy field in Bronze Age Germany, we crossed the Atlantic to a book that survived the burning of an entire civilization, the Dresden Codex Venus Table. The Spanish conquistadors burned nearly every Mayan book they found. Of the thousands of codices that existed, 4 survived. Open one of those survivors, the Dresden Codex, named for the German city where it ended up, and turn to pages 46 through 50. What you are reading is a 104-year almanac of the planet Venus, calculated with a precision that European astronomers would not match for another 3 centuries. Archaeoastronomer Anthony Aveni of Colgate University, in his landmark work Sky Watchers of Ancient Mexico, established that the Mayan Dresden Codex tracks Venus's 584-day synodic cycle, the time it takes Venus to return to the same position relative to Earth, across a 104-year table encompassing 65 Venus cycles and 146 ritual calendar cycles simultaneously. The accumulated error across the entire 104-year period amounts to 2 hours. Not 2 days, 2 hours. The table interlocks 3 separate Mayan calendars at once, the 260-day Tzolk'in, the 365-day Hab, and the 584-day Venus cycle, resynchronizing every 104 years. Epigrapher David Kelly identified internal correction tables within the codex, compensating for fractional day drift in the Venus cycle. Mathematical sophistication equivalent to modern decimal correction in navigation software. The mainstream explanation credits centuries of meticulous naked-eye observation and institutional record-keeping. That is fair. But centuries of naked-eye observation producing 2-hour accuracy across 104 years requires an unbroken tradition stretching back far longer than the Maya's documented history. Every generation that failed to record compounds error. The Dresden Codex isn't the origin of this knowledge. It is supposedly a copy. The question is, a copy of what? From a calendar built around Venus, we move to clay tablets from Mesopotamia, and eclipse predictions so accurate they imply a record stretching back centuries before Babylon even existed. The Babylonian Saros cycle eclipse tablets. Close your eyes and try to predict a solar eclipse, not the next one. The one that will happen in 18 years, 11 days, and 8 hours from now. To derive this from scratch with no prior data, you would need 18 years of continuous unbroken records. Miss 1 month, 1 cloudy sky, and the chain breaks. The Babylonian astronomical diaries, systematic nightly sky records inscribed on clay tablets, were studied in depth by Danish historian of science Asger Aboy, whose 1974 paper in Philosophical Transactions of the Royal Society demonstrated that Babylonian Saros series predictions match modern retro-computed eclipse data with errors of less than 30 minutes. The earliest surviving Babylonian eclipse record dates to 747 BCE. But John Steele of Brown University, in his study Observations and Predictions of Eclipse Times by Early Astronomers, showed that the Saros series the Babylonians were already using had been running for 38 eclipse cycles before the earliest surviving tablet, meaning observations began no later than 1000 BCE. The Enuma Anu Enlil, a series of 70 clay tablets recording omen-based astronomical events, contains eclipse observations in precisely the same mathematical language as the later diaries, suggesting an unbroken tradition spanning at least 600 years. Babylonian astronomer Kidinu, working in the 4th century BCE, calculated the synodic month, the time between two full moons, as 29 days, 12 hours, 44 minutes, and 3.3 seconds. The modern accepted value is 29 days, 12 hours, 44 minutes, and 2.9 seconds. The difference is 0.4 seconds. Mainstream historians credit this to iterative mathematical refinement across generations. But the mathematical models embedded in the tablets assume a theoretical understanding of why the cycle continues, not just that it has continued before. Where did that theory come from? And where are the records that built it? From the banks of the Euphrates, we travel east to ancient India, where a Sanskrit text calculates the length of the solar year in numbers that should not have been possible. The Surya Siddhanta, a Sanskrit astronomical text composed around 400 CE, opens with a claim so staggering that scholars spent centuries filing it under mythology, that its contents were dictated by the sun god himself to the sage Maya at the beginning of the current world age millions of years ago. Set the mythology aside for a moment. Look at the numbers. The Surya Siddhanta's calculation of the sidereal year, the time it takes Earth to complete one orbit relative to the fixed stars, is 365.2563627 days, compared to the modern value of 365.25636 days, a difference of approximately 1.4 seconds. It is worth noting that this comparison uses the sidereal year. The Surya Siddhanta's figure for the tropical solar year, the one that governs seasons and calendars, runs roughly 3.5 minutes longer than the modern accepted value, a discrepancy scholars have long noted. The 1.4 second figure is real, but it applies specifically to sidereal measurement. Historian of mathematics Kim Plofker of Brown University, in her foundational work Mathematics in India, confirmed the Surya Siddhanta's sidereal year is indistinguishable from the modern value at the precision recorded. The text also calculates the Earth's diameter within 1% of the modern figure, the distance to the Moon within 0.2%, and the distance to the Sun within 5%. It uses a base number of 4,320,000 years for the Mahayuga world cycle, a figure divisible by every known astronomical period, including the synodic months of all visible planets, suggesting it was reverse-engineered from observational data rather than invented. Scottish mathematician John Playfair calculated in 1790 that the Surya Siddhanta's planetary parameters implied continuous astronomical observation beginning no later than 4300 BCE. The mainstream explanation credits Gupta period astronomers with synthesizing centuries of observation with mathematical refinement inherited partly from Babylon and Greece. But the Surya Siddhanta itself explicitly rejects foreign origin, claiming knowledge from an age that predates recorded history entirely. The 1.4-second accuracy for the sidereal year is genuinely remarkable for a text composed 15 centuries ago. Whether it reflects instruments, iterative mathematical refinement, or inherited observational traditions remains an open question, and one that scholars of Indian astronomy continue to debate. From a text that claims the sun as its author, we move west to a 24-ton stone disk that encoded not one calendar but 5 world ages, all ending in catastrophe: the Aztec Sunstone. You are standing in the National Museum of Anthropology in Mexico City, staring at a basalt disk 12 feet across and 24 tons heavy, carved with such density it contains 5 nested calendar systems, a cosmological history of the universe, and a 0 date, the beginning of the current world age, of August 11th, 3114 BCE. That date is not unique to the Aztec Sunstone. It is the exact same 0 date encoded in the Mayan long count calendar, used by a separate civilization, speaking a different language, writing in a different script, centuries earlier, hundreds of miles away. Neither culture left a record of agreeing with the other. Alfonso Caso's systematic decoding of the Sunstone, developed across his career and summarized in works including his 1958 study and his 1967 Los Calendarios Prehispanicos, established that the stone encodes the 52-year calendar round, the point at which the 260-day ritual calendar and the 365-day solar calendar resynchronize, tied to the heliacal rising of the Pleiades. The new fire ceremony that concluded each 52-year cycle was not metaphor. Aztec priests extinguished every fire in the empire and waited on a hilltop to watch whether the Pleiades would cross the zenith at midnight, confirming the world would continue. The 5 world ages depicted on the stone's inner ring, each ending in a different catastrophe, have been mapped by some researchers to actual geological epochs preserved in the stratigraphic record. The disk was deliberately buried face down beneath the central plaza of Tenochtitlan when it was discovered in 1790. The mainstream attributes the shared 0 date to cultural diffusion through the earlier Olmec civilization. But that simply moves the question back. What astronomical event did the Olmec witness in 3114 BCE that was significant enough to make it the 0 point of a calendar system inherited by every civilization in the hemisphere? Modern astronomy has not identified a candidate. From a buried stone in Mexico, we cross the Atlantic to the Nile, and a calendar so accurate it predicted river floods to within a single day for 2,000 years. The Egyptian Sothic calendar. Every year, on one specific morning in mid-July, the star Sirius rises just before the sun on the eastern horizon, visible for the first time after 70 days of invisibility. To the ancient Egyptians, this was not poetry. It was a mechanical alarm clock coded into the sky itself. The Nile would flood within 2 weeks. For millennia, they were right. The Egyptian civil calendar contained exactly 365 days with no leap year correction, meaning it drifted 1 day every 4 years relative to the actual solar year. The full drift took 1,460 years to complete, a period Egyptologists call the Sothic cycle. German Egyptologist Eduard Meyer, working in 1904, established that when Sothic observations recorded in ancient texts at 239 BCE and 139 CE are used to work backward the calendar's original 0 point, when Sirius rose on New Year's Day, falls in either 4240 BCE or 2780 BCE. The 4240 BCE date would make the Egyptian calendar the oldest precisely dated event in human history. When researcher R.A. Wells extended the calculation further, accounting for precession and the proper motion of Sirius itself, the original alignment pushed back toward 11,000 BCE. The Palermo stone contains Sothic references dating to the First Dynasty around 3100 BCE, suggesting the calendar was already institutionalized at the dawn of recorded Egyptian history. Otto Neugebauer, in The Exact Sciences in Antiquity, verified that a papyrus from the reign of Pharaoh Senusret III around 1872 BCE records a Sothic rising precise enough for modern chronological anchoring. The mainstream says the calendar was developed empirically around 2780 BCE. Ancient peoples, however, did not project backward to invent zero dates. They started counting from something they witnessed. Someone was watching Sirius rise over the Nile before writing existed. Who handed the Sothic system to the priests of Heliopolis as something already ancient? From the banks of the Nile, we make our final journey, high into the Andes, where an entire city was built as a calendar that only makes sense from above. The Inca Seque calendar system. Look at a satellite image of Cusco, Peru. You see a city. Now, look at a colonial-era map that traces the sacred lines the Inca called seques. 41 invisible rays radiating outward from the Coricancha Sun Temple at the city's center, connecting 328 shrines scattered across the surrounding landscape. Look again. What you are looking at is not a city, it is a calendar. The entire physical geography of the Inca capital, every spring, every hilltop, every sacred rock, was placed, measured, and named as a working astronomical almanac. They did not write it down, they built it out of mountains. R. Tom Zuidema of the University of Illinois first proposed the system's astronomical function in his 1964 dissertation. Anthony Aveni, in a study co-authored with Zuidema and published in American Antiquity in 1981, demonstrated that specific sec lines align with the rising and setting of the Pleiades, the June solstice sunrise, and the anti-zenith sun passage, with angular accuracy of less than 1 degree. The 328 shrines correspond to the 328 days of the Inca agricultural calendar, 12 sidereal lunar months of approximately 27.3 days each. The remaining 37 days of the solar year were a sacred uncounted period corresponding precisely to the interval when the Pleiades disappear from the Andean sky. Brian Bauer and David Dearborn's 1995 study Astronomy and Empire in the Ancient Andes physically confirmed the locations of more than 200 shrines, many showing evidence of astronomical sighting markers. The Coricancha temple at the system's center was oriented so that at the June solstice, sunlight entered a specific chamber and illuminated a golden solar disk, accurate to within 1 degree. The mainstream accepts this as genuine achievement, a landscape-based record-keeping system substituting for writing. But here is what that explanation accepts without confronting. The Inca arrived at the same astronomical answers. The Metonic-adjacent sidereal lunar month, the Pleiades as calendar anchor, the solstice alignment, as the Babylonians, the Maya, and the Vedic astronomers independently across oceans with no documented contact. The third time, the same answer appears on a different continent. It stops being coincidence. Perhaps the Seque system was not invented by the Inca. Perhaps they built their capital where they did because the landscape was already sacred, already aligned by someone who came before. 10 calendars, 6 continents, a time span stretching from 10,000 BCE to 1500 CE. Every one of them tracking the same sky with a precision that humbles modern instruments. every one of them implying a tradition older than the civilization that used it. The mainstream offers a coherent answer, convergent observation. Smart people, given enough time and motivation, figure out the same things. It is a fair answer, and for many of these cases, it is probably right. But it does not easily explain a 1.4-second sidereal year calculation made 15 centuries ago. It does not explain the 2-hour Venus accuracy across 104 years. It does not explain the zero date shared across civilizations that, according to the official timeline, never met. What it does explain is why we keep asking. Most people walk past these artifacts in museum cases and see nothing but ancient curiosity. You made it here, which means you see what they actually are, fragments of a longer conversation, one that started before writing existed and is still being decoded. This channel is built for the people who refuse to stop decoding. Hit subscribe and drop a comment telling me which of these 10 you think is the hardest to explain away. Make your case. The floor is yours. These are not 10 separate mysteries. They are 10 windows into the same room. A room where someone was reading the sky long before history says they could. The question was never whether they knew. It is who taught them. Subscribe, and let's keep looking.